Hello everyone, welcome back to the channel and Infosec Pandey here. So today's day 35 of SOC 100 days learning challenge. Today we stop being alert monkeys and start thinking like detection engineers. So what we will cover in this video, so we are going to discuss about what is correlation rule, what is the importance of the correlation rule, how to write correlation rules in SIEM. So basically we will go through with the correlation rule. All right, so what is correlation rule? So correlation rule is like a connecting multiple events to detect real attacks. So we can say a correlation rule is a smart logic in SIEM. So whether you are using Splunk, ArcSight, Sentinel, or any other SIEM platform, you are going to see correlation rule a lot. So this is a smart logic in SIEM, and instead of alerting every single events, it says if a event A happens and and event B happens within a specific time, so let's say 10 minutes, then trigger an alert. So it connects behavior and provide the real attacks. All right, so I can provide a simple example here. So suppose login from one country is a normal behavior, but login from new country plus password reset in 5 minutes, so that's suspicious, right? So if somebody log in from one country, that's normal, but if somebody log in from a new country and then resetting password in 5 minutes, so that's suspicious activity, and that's the correlation rule. So this is called correlation rule. Now you might ask why custom rules matters. So basically the SIEM have default rules. So suppose you're using a Splunk or Sentinel or QRadar, they always comes with out of box connector, out of box connectors, and that out of box have some inbuilt rules, right? So we should not use the default rule because attackers know those rules too. So if you only depend on default rules, you are going to detect only the common threats, but you are not going to get the advanced attacks. And also you are going to miss the environment specific threats because those are very default rule. So there might be the threshold common, and also time is common, and there might be country is common in the default rule. So we should not use the default rule. We should only uh, like use the custom rules and also tune it according to our environment. So we can say why these rules matter. So it matters because we need to detect threat specific to our environment, right? Specific to environment, and also it is going to reduce the false positive because everything is tuned and as per your requirement. And also this help detecting behavior chain, and also this looks good on your resume. So if you know how to write the custom rules, you can impress your interviewer. So I'll give you one example here. So suppose your company have only 200 employees and you do not have any international users. So suppose I'm in India, so uh, like company have only Indian employees, but then if you see login from Pakistan at 6 a.m., then it is like high risk, right? Or login from Russia at 1 a.m. So this is going to be high risk, right? But your default rule might not detect it threat because it doesn't have that rule set. So you need to define your employees are in India, not in all over the world. So the custom rule will help you to detect these kind of attacks. All right. So now you will ask what are the components of a good correlation rule. So let's talk about the components. So let's list it down. Number one, use case. Number two, log source. Number three, trigger condition. Number four, time range or time window. And number five, alert action. Now let me explain everything in detail so it will help you to understand what exactly these are. So use case, like what use case you have. So if I talk about the use case, then what you are trying to detect. Use case means what you are trying to detect. Detection. Okay. So for example, you are trying to detect the lateral movement in your environment, lateral movement, or you are trying to find all the data exfiltration, or you are trying to understand brute force or any ransomware behavior. So this is called use case. All right. So without clear use case, you are going to create a very bad rule. So use case is very important part. And then we have log source. So if I say log source, then log source is like your real data, your Windows machine, your Linux machine, your AWS environment. So what data do you need? So this is clearly provide the data requirement. So because data is king here, so without data you cannot create a use case or cannot detect a threat, right? So data source examples are Windows logs, Windows security logs, and then firewall logs, right? Also VPN logs, your EDR solution log, your DNS log. There are a lot of log sources available. So remember one thing: no log, no detection. Then the next we have is trigger condition. So trigger condition is going to define what exactly must happen. So for example, if more than 5 failed logon or more than 10 file downloaded in 5 minutes, or we can say login from two or more country. So login from two or more country in 5 minutes. So these are the logics, the trigger conditions. This is going to be defined in the use case. So be specific when you create trigger condition or use case. Then time window is also very important part in the use case. So time window, like so time window equal to your behavior that must happen within x minute, hours, days, etc. For example, if 5 failed login in 1 year, 5 failed login in 1 year, that's pretty normal, right? That's normal behavior. But 5 failed login in 2 minutes, so that's suspicious. Somebody trying to enter the credentials, and time is mattering here. And then next we have alert action. So this is also very important part. Alert action. So what happens when these rule matched? So this is going to be defined in this section. So what happens next? So if something the like if the condition is matched, then what is going to be happen next? So we have some examples here, like creating incident or sending email notification, send email, trigger SOAR playbook. So SOAR playbooks are the automated response playbooks that can take action as per your requirement. Notify SOC. So rule without actions are useless. So if you do not have any alert action, then it is useless. Now we have some examples here. So the example number one is lateral movement. So when attackers compromise one system and they try to log in into many systems, so that's the lateral movement. So if they got access on one system and trying to access the multiple systems, so that's the lateral movement. So what we detect here, so we are going to detect whether it's the same user and logging into multiple host. So if somebody same user logging into multiple host, multiple systems in a short time. So this is the lateral movement rule. Okay, so you can write the logic like that. So if user logs into more than 5 different hosts, and then also we are going to define the time here within 10 minutes, then alert. So here we have all the uh, requirement for creating a custom rule. So if user like attacker or normal user login into more than 5 different systems within 10 minutes, then alert it. So this is the logic for the alert. So what happens usually? So the normal user usually log in into one or two system, and attackers move quickly. They log in one machine, then go on the second, then third. So that's the behavior based detection. And let's build one. So the step number one would be identify the threat. So suppose we are looking for the exfiltration of the data, exfiltration data. So what attacker do? Attacker basically come and collect all the files and then compress them. So suppose they have 1 TB of data and they compress it for few GBs, X GBs, and then send it to outside. So suppose they are into your organization and they have all these files and they going to send it to the command and control server, which is might in Russia or some other country. So they are going to send it. So that's the data exfiltration. So this is what we are going to identify. Then the next step we have translate to behavior. So behavior is bigger than tool. So we don't detect hacker.exe, hacker.exe, we detect behavior. So large number of file downloads. So suppose if somebody is downloading large number of files, suppose they downloaded 10,000 file followed by an outbound connection. So suppose they are visiting on a file called visiting on a website called hacker.x.com, and they have an outbound connection on this website, and from there they downloaded 1,000 files, and the domain or IP is rare. So this is the behavior. So this is not normal, right? Then we have step number 3, which is called map to logs. So we need to understand the logs first. So we need to understand file events, where exactly we can get all the file events. So the file events in Defender exist in device file events. So that's the schema, or we can say the table where all the file related activity stores, and where we can find the network log. So we can find the network log on network connection. So always map behavior to your available log. So if you understand where to check the data, then it is easy to map the logs. Then the next step we have build rule logic. So now we can write our logic here. So the logic would be for this scenario. So the logic would be if user download more than or equal to 10 files and connect to IP, which is rare, and here is the time within 5 minutes, then alert. Now you can translate this logic into your query language like SPL or KQL or EQL or any query language that you're using. So always design your logic first, then convert it into SIEM query. So what are the common mistakes that everybody make while creating the detection rule? So the first is creating too broad rule. So if you are creating too broad rule like alert on every failed login, SOC will hate you. Number two, creating too complicated rule like too many conditions with single alert. So no alerts ever trigger. So balance is a key here. So you need to make the balance between your conditions and your logic. So you get some events as an alert. Then also the common mistake is no testing. So suppose you created any rule and you deployed it, and uh, you haven't tested it, then it is not going to trigger, or you are not sure whether it is going to trigger or not. So always test your rule in every 30 days or every 60 days, and ask, does it trigger too much or does it miss the obvious cases? So test triggers or miss. So always test your deployed use cases, and this will help you to identify which rule require tuning. And the another mistake beginners make, tuning. All right, so after deployment, adjust the threshold, and also add some exclusions like whitelisting and blacklisting, and then also you can refine the logic. So these are the major elements that can be used for tuning. So remember one thing, detection is continuous improvement process. So tune your rule regularly. So review it at least in 60 days or 90 days. All right, so let's talk about some correlation ideas. So the first idea we have is like login plus mass file deletion. So this is going to tell you if somebody logged in and then deleted a huge file deletion. So this is a suspicious activity, and how you can detect it. So you can correlate the multiple logins like authentication logs or your Windows security logs, and then file events. Then second we have VPN login plus MFA disabled. So this is another activity that we should create in our environment. So this is another suspicious activity that we should monitor in our environment. And the third one we have same user from two countries in 10 minutes. So this is like a time travel. So we need to create a correlation rule for it. And then new service created plus PowerShell execution. So this is another suspicious activity that we can identify using the correlation rule. And then the fifth we have rare DNS query plus outbound traffic, because attackers loves DNS. These are the not simple rules. These are the behavior chains. All right. So what are the advanced mindset? So good analysts react to the alert, and great analysts they think like a attacker, and they break attack into stages, and also they detect each state connection. So MITRE attack is gonna help here. So if you go through the MITRE attack mapping, you will be able to understand the a complete attack scenario. So if you see some alert in the initial stage and then persistence, lateral movement, impact, you just dig it. So your correlation rules should follow attack life cycle, and that's how you move from tier 1 to detection engineer. All right, so let's wrap it up. And what is the key takeaway? So we learned about the correlation rules. So basically the correlation rules are, so correlation rule help reducing the noise, and then also increase the real detections, and also it shows your thinking ability. So we can say SOC heroes are not born. They write better rules every day. So if you want to become a good detection engineer, just write some correlation rule and explain it to your manager. So if you like the video, like and subscribe. Thank you so much.